Okay, guys, we've made it to like our Super Bowl, which is the unit circle. So, first thing I want you to know is it looks intimidating as it is right now, but you guys know everything. We've literally, everything I've done has been leading you up to this point. So, I believe in you. Let's talk about it. First thing I want you guys to do in this top corner is label all students take calculus. In quadrant one, which is this area, so I'll put it in Roman numeral, quadrant one, that's this quadrant. All of your signs, all trig function signs are going to be positive. So I'm going to put all trig functions are positive. We have quadrant 2 over here. In quadrant 2, only the sine functions are positive. So sine of theta is positive. That means cosine of theta and tangent of theta are both going to be negative. Keep in mind, guys, even though I'm not putting the reciprocals, the reciprocal for sine is cosecant. So that would also be positive. And then for cosine, the reciprocal would be secant, and then the reciprocal for tangent would be cotangent. Those two would also be negative. Even though I'm not writing all of those, you don't need them right at this point. So there's methods to my madness. Down here, in this bottom quadrant here, this is quadrant 3. In this quadrant, you have tangent, that's positive. Meanwhile, sine and cosine are both negative. And then in the last quadrant, we have quadrant 4. In quadrant 4, cosine of theta is positive, and tangent and sine are both negative. I like to use different colors for this. Y'all know how I am, so I'm going to actually use some different colors as I go through each of the pieces. If you have extra colors available, beautiful. Use them because you will thank yourself when you're going through this later. Okay, first thing that I want to do is I want to label everything I know in quadrant 1. It seems intimidating, but we're just focusing on this piece. Let me zoom in. We're just focusing in that first quadrant where all of your signs are positive. We're going to talk about the degrees. We're going to talk about the radians, and we're going to talk about the coordinates. So let's start out with the degrees. We have 0. We have 30 degrees. We have 45 degrees, 60 degrees, and 90 degrees. Write the radians for each of those. Radians would be 0. This is pi over 6, pi over 4, pi over 3, and pi over 2. Next thing we need to look at is, now let's look at the coordinates. If you think back at pages that we've done before, we've literally been doing this for the past several classes, but we've been making this little chart on almost every single page we have done. That tells me the x and y coordinates for literally 0, pi over 6, pi over 4, pi over 3, and pi over 2. So we're going to recopy these, and we're going to put them on this paper here. So in this first quadrant, at 0, 0 degrees, 0 radians, we're going to put 1, 0. This is your cosine of theta. This is your sine theta. This is your x. This is your y. We literally wrote that right here. 0, square root of 0 over 2 is just 0. Square root of 4 over 2 is just 1. We've already done that. This is your y. This is your x. I'm just literally going from my chart, guys. I'm recopying it here. So at pi over 6 for cosine, that's your x. That's going to be square root of 3 over 2. And this is going to be 1/2. At square root of 4, pi over 4, this is going to be square root of 2 over 2, square root of 2 over 2. Probably my favorite because it's the same. At pi over 3, we're going to have 1/2, and we'll have square root of 3 over 2. And then at pi over 2, we have 0 and 1. Okay, cool. We've labeled a bunch of things that we already know. I'm not going to worry too much about the coordinates right at this moment. I'm going to worry about the radians. Let's focus on one thing at a time. So we've labeled everything we know in this first quadrant. What we're going to do now is we're going to break it up into smaller pieces. So in our notes, we went over quadrantal angles in the unit circle. So this guy here, we actually talked about how to break up your unit circle, let me zoom this out, into smaller sections. So for instance, when we had pi over 2, we said that with your denominator of 2, you're going to have 2 sections in the first part of your semicircle, so at the top, and then 2 parts at the bottom part of your semicircle. Same thing if you had pi over 4. You can break it into 4 sections at the top, 4 sections at the bottom. And then, of course, we went all the way over here to pi over 6 after we did pi over 3. We saw there were 1, 2, 3, 4, 5, 6 sections in the top, and then 1, 2, 3, 4, 5, 6 sections at the bottom. We're going to do that same kind of logic here, because remember, we're creating the unit circle. So we have pi over 6 here. Pi over 6 means there needs to be 6 sections in just the top part of this little semicircle. So I know we have a couple of different things, but keep in mind this is one section. This section here, even though it has 2 in here, that's your second section. And then here's your third. So we're going to start counting around the unit circle by pi over 6. This will be 2 pi over 6. This will be 3 pi over 6, 4 pi over 6, 5 pi over 6, and then over here we'll have 6 pi over 6. I want you guys to do the same thing, but for the bottom. Go from 6 pi over 6 all the way around to here, which is the same as 2 pi, which I will write as 12 pi over 6. So rewrite that as 12 pi over 6, and I want you to label all the way around. Which sides do you think are going to be pi over 6 units? Write it, keep going around and counting. This will be 7 pi over 6, 8 pi over 6, 9 pi over 6, 12 pi over 6. Whoops. Clearly can't count today, guys. Sorry about that. That's 10 pi over 6 and 11 pi over 6. Clearly, I'm just trying to get this done. Okay, but what I want to do is I want to actually look to see what my numbers are. Because as you notice in this first quadrant, pi over 6 is the same thing here. Pi over 3, though, is that the same as 2 pi over 6? If you divide both of these by 2, that reduces to pi over 3. 3 pi over 6 reduces to pi over 2. 4 pi over 6, what does that reduce to? That reduces to 2 pi over 3. 5 pi over 6 doesn't reduce, so I could just rewrite it as 5 pi over 6. And then, of course, 6 pi over 6 is the same thing as pi. Remember, I told you guys this a while ago. Make sure whenever you're writing out your unit circle, whatever your denominator is, make sure you immediately go from 0 all the way over to pi, which in this case is 6 pi over 6. We're going to keep labeling. 7 pi over 6. 8 pi over 6 can reduce to 4 pi over 3. This will be 3 pi over 2. Oops, let me put on the radian side. 3 pi over 2. And then we'll also have 10 pi over 6, which is 5 pi over 3. And then we'll have 11 pi over 6, which unfortunately cannot reduce. Okay, cool. See, guys, we're slowly getting the unit circle together. All right, let's use a different color. I have, if you look on the inside, all of the items in pink, and technically this light blue, we almost have everything written in. I could actually rewrite this as 2 pi, because we already said 12 pi over 6 is the same as 2 pi. Let me think. The only other numbers that I'm missing are these. There's like a couple that are missing, in radians. This one, and this one here. Okay, well, that represents pi's over 4. Okay, so let's look at pi over 4. Pi over 4 means if you break this into 4 sections for that first semicircle at the top, you'll have pi over 4. You'll have 2 pi over 4, which we hopefully already know reduces to pi over 2. We'll have 3 pi over 4. We'll have 4 pi over 4, which again reduces to pi. We'll have 5 pi over 4, 6 pi over 4, and we'll have 7 pi over 4, and then 8 pi over 4. If you look at where my purple numbers are, they are showing the 4 sections. So here, that's one section. Here, this is a second section. Here, third, and then fourth section. So I have it broken up into 4 parts. All I need to do from here is see if any of these numbers reduce and then write them in their radian spot. So this is 3 pi over 4. We have 4 pi over 4, which is pi. We have 5 pi over 4. 6 pi over 4, which reduces to 3 pi over 2. And then we have 7 pi over 4. And remember, 8 pi over 4 is the same as 2 pi. And then, of course, we had pi over 4 here, which I didn't need to relabel. And then we said it before. 2 pi over 4 reduces to pi over 2. Okay, we're almost done, guys. We're almost done. We're going to look now at the degrees, or excuse me, the coordinates. So for the coordinates, let's just take a second and look. Even though I wrote them just like this, I have the radians and, the exact values from my unit circle table. I also want you to keep in mind that you guys told me when we first started doing it, there was a pattern. And it went from 0 up to 4, and then from 4 down to 0. Okay, well, let me rewrite this over here. For 1, this is the same as the square root of 4 over 2. And this is the same as the square root of 0 over 2. And I'm going to do that for this point as well. This is going to be the same as, I think I'm going to have to put it on top, square root of 0 over 2 and the square root of 4 over 2. That's for this coordinate down here. What that's going to help me do is try to figure out a pattern that will help me with writing out my answer. Well, we said before on our little chart that the numbers go up as you go from 0 over to pi over 2. So 0, 1, 2, 3, and 4, which is here. Cosine kind of decreases. It goes from 4 to 3 to 2 to 1 to 0, which is 0 over the square root of 2, square root of 0 over 2. We're going to use that exact same pattern to label this one here. Don't worry about the numbers that are in this first quadrant. Let's just focus on this. I know that my point here is 0 over 2 and 4 over 2. I know that this point on the unit circle is negative 1 comma 0, which is the same as the square root of 4 over 2 and square root of 0 over 2. If you know how to count, guys, you should be able to write your side of your triangle or your side of your unit circle without me. If not, remember, this is cosine theta, this is sine theta. For cosine, this one should be going down. The number should be decreasing. 4, 3, 2, 1, 0. So I want to see the same thing here. 4, 3, 2, 1, and then 0. We're going to divide these by 2. Notice that I put the square root. I don't need to put the square root of 1 because technically the square root of 1 is just 1, like we see here. Square root of 1 is just 1. But I'm just going to write it in something easy that you guys can easily remember. Once I have that written out, let's write the signs. Okay, sign should be increasing. 0, square root of 1, square root of 2, square root of 3, and then square root of 4 for this top point. We're going to divide all these by 2. That's a 2, and this is a 2. That's it, guys. That's all you have to do. The only other thing I need to remember is that sine is positive while cosine is negative. Cosine is all of the x's, so make all of these x's negative. Except for this one, of course, because this is right on the y-axis. Okay, let's look at the bottom part. Down here, I know that I'm going from square root of 4 over 2, which is negative 1, and 0 over 2, which is 0. I want to go ahead and write down my bottom portion in quadrant 3 based on the pattern that we were just talking about. Also remember that this point down here is 0, negative 1, which is the same thing as square root of 0 over 2 and square root of 4 over 2. Let me actually put that as a negative because that's what I was thinking about doing. Put that as a negative. Okay, so let's go ahead and think about it. Cosine needs to be counting down. You need to be going from 4 down to 0. So we're going to write this as square root of 3 over 2, square root of 2 over 2, square root of 1 over 2. And it gets down to 0. Sine is your y-coordinates. These need to be increasing. They need to be going up. So we're going to make this square root of 1 over 2, square root of 2 over 2, and square root of 3 over 2. And then remember, it'll get down to 4 over 2. Those are my coordinates, guys. Most I might need to do is simplify this square root of 1 and the square root of 1, but that's pretty much it. The last thing before I move on to quadrant 4 is I want to make both of my signs, the actual positive negative sign, negative for both. So I'm going to bold my negative in blue. And that's for all of them in this quadrant. Use that pattern, guys, to label this quadrant. Okay, so let's look at it. Okay, I'm going to start from, I know you're like, wait, where do I start from? Okay, well, let's start from the x-axis. Whenever you're writing these out, let's start from the x-axis to make it easier. Okay, so I know that 4 over 2, especially for cosine, if you think back to the chart that we've been making, 4, 3, 2, 1, 0, let's follow that pattern. So the only way to follow that pattern is if I use this guy. Because remember, cosine down here is 0, which is not going to be good to help me with writing it out. So let's start with this 4. We're going to do square root of 3 over 2, square root of 2 over 2, square root of 1 over 2. And then we get down to 0, which is down here. For sine, you should have counted up. So it's starting at 0. We're going to do square root of 1 over 2, square root of 2 over 2, and square root of 3 over 2. The last one is square root of 4 over 2. I need to check my sign that needs to be negative is the sign, so the actual y value. So let's make all of these y values negative. The last thing we have to do for our unit circle, guys, and then we're pretty much done, is label the degrees on the inside. So on the inside of this, I have all of my degree blanks. I know this is 180, just from going through problems. I won't put the degree because it's already there. And this is 270. Try to figure out what the other ones are. Oops, sorry, in this one, 360. Try to figure out what all of the other angles are. This is 120. This is 135, 150, and then you get to 180. As you continue to go around, this is 210, this is 225, 240, and then 270. In the last quadrant, we're going to have 300, 315, keep putting that degree, sorry about that, and then 330. And then, of course, 360 is this guy here. It seems like a lot, guys, but this is your unit circle. And I'm very proud of everything that you guys have done. This is your unit circle. So if you notice, this page is front and back. It's double-sided. So on the back side of this page, it's completely blank. What I want you to do without cheating, don't look at your notes, don't look at the other side, flip it over right now, come on. And I want you to actually try to fill in as much as you can from memory on this unit circle. So fill in as much as you can right now. Pause the video and fill in as much as you can from memory without flipping. If you get frustrated and need to flip, I understand it. But do not recopy it. Try to see what you can do from memory. Go ahead and pause the video right now. So, based on what you guys have learned from seeing what you can do on your own to this guy here, which we've already done together, don't feel bad if you couldn't fill out the entire unit circle on your own. Don't feel bad. However, it gives you an idea of the different discussions that I had with you and the patterns that I asked you guys to notice and the things that we've discussed before that I'm bringing to this chart that you guys see. Don't stress out. I have plenty of extra copies of the unit circle in my class. So if you want an extra copy, just grab one. Let me know or let your teacher know and you'll be able to get one. But this is what you need, guys. This is all you need. So take time. If you want me to give you extra copies, just stop by my room. But take time to actually practice writing this out from memory. Start with one thing at a time. Start with the radians. Then start with the degree. Then try to actually get the coordinates in each quadrant. But don't overwhelm yourself. You can do this. All you need is just to remember the conversations we had. There's 6 different things. We talked about the quadrants, the signs in each of the quadrants. The second thing we did was we talked about how to break up the unit circle into pi over 6. We then talked about how to break up the unit circle into pi over 4. After we talked about that, we also looked at the pattern that we saw from from cosine, which is going from 4 to 0. And then we talked about the pattern we saw with sine, which is going from 0 to 4. We took that pattern, guys, and we just recopied it all around your unit circle. Keeping in mind the all students take calculus, the positive and negatives that we talked about at the beginning. The last thing that we talked about is the degrees. The degrees, guys, are just literally adding and subtracting between 30, 60, and 45 degrees. I believe in you guys. I know you can do it. It just takes practice. If you don't practice, guys, you're not going to get good at it. So when you're in my class again, take a couple extra copies of the unit circle, and when you feel a little stressed and you want to calm yourself a bit, try to see if you can do the unit circle. It might help. If you have any questions, guys, or need help, please let me know.